This is lessons 1.3 and 1.4. The midpoint is exactly what it sounds like. It's the middle point. It's the point halfway between the endpoints of a segment. So a midpoint bisects a segment. They want to know on this number line, if I were to consider segment AD, what value would be the exact middle between -12 and 18? So the exact middle, if I counted the number of spaces, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 5 spaces apart would be the middle. So if we count 1, 2, 3, 4, 5, they puts us solidly right here at 3. If I'm looking at a way to get to 3 using the -12 and 18, if I took -12 plus 18, I get 6. And if I cut it in half, I get 3. So what I've really done is I found the average. So if this is the x value of A and this is the x value of D, the average of them gave me the x value of the midpoint. So the same can be applied to points that have ordered pairs. The x value of the midpoint would be the average of the two original x's, so x1 plus x2 over 2, and the y value would be the average of the y's. And that would be our formula for the midpoint. So midpoint is a point is an ordered pair. So let's find the midpoint of segment PQ. So x sub 1 and x sub 2. So that means we're going to do 7 plus 3 over 2. And then we have y1 and y2. So that's going to be -2 plus 8 over 2. So we do want to simplify this. So this is 10 over 2, which is just 5, and 6 over 2, which is 3. So the point 53 is the exact middle of P and Q. Here's a try problem. If you want to do it, pause. Answers are posted online. The midpoint of segment RP is M, 2, 4. You know that R is -1, 7. Find the coordinates of P. So we can do this algebraically, but I actually find it's easier to look at it if I put the R and P at the two ends and M in the middle, because M has to be the midpoint. And I'm going to list the things I know. I know R is -1, 7. I know M is 2, 4. But I don't know what P is. Since this has to be exactly in the middle, whatever it takes to get me from -1 to 2, which is increasing by 3, should be the same thing that happens to get from 2 to the next value. So if I increase 2 by 3, I get 5. Same thing for the y's. To get from 7 to 4, I decreased by 3. So now from 4, if I decrease by 3, I get 1. So that means the ordered pair for P is really 5, 1. This is another try problem. You can pause if you'd like. Answers are posted online. For example 3, M is the midpoint of segment VW, find VM. So this diagram has actually been a little helpful. Sometimes when they tell you it's a midpoint, they're not going to already have it marked for you that those two things are congruent. But this time they did. So even though they told us it's the midpoint, they did show us those are congruent. So I'm going to set them equal to each other. So I have 4x minus 1 equals 3x plus 3. So that's going to be x equals 4, right? Subtract 3x, add 1. So I still want to find the length of VM. So I'm going to take my 4 and substitute it back in. So 16 minus 1, VM is actually equal to 15. All right, and try 3. If you want to do it, you can pause. Answers are posted online. Distance. The term distance is used interchangeably with length when referring to a segment. So it is the length of a segment or the distance between the two endpoints. If I were to look at these graphed points that are already connected by segments, if I wanted to find the length of AC, because it is a vertical line, I can actually count the boxes that have formed, or noticing that they had the same x value, I could find the difference of their y's. So if I counted, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And also the difference between 8 and -4 is 12. For BC, a horizontal line, they have the same y values. So again, I could just count the boxes here or find the difference between the x's. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8. And again, 3 minus -5 is 8. But then we get to segment AB, and that's where it becomes a little trickier, because I cannot count boxes that move diagonally. So if we think back to what we've learned about triangles in past years, we know that this is a right triangle. So really, I can do the Pythagorean theorem to find out how long my side C is. And in that case, we would have C squared equals A squared plus B squared. I know you've probably seen it as A squared plus B squared equals C squared. This is the same thing. In which case, if I took the square root of both sides, I end up with C equals the square root of 12 squared plus 8 squared. This is actually a formula called the distance formula, where we start with the square root of something squared plus something squared. And we find these two values by finding the difference in the x's and the difference of the y's. So the actual formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So if I were to actually do that work now, instead of relying on my Pythagorean theorem, because almost always we will not have a picture drawn, we will have to just be able to find the length of a segment, so we will definitely be using the distance formula a lot. So I'm going to say AB equals, and I'm going to take x sub 1 minus x sub 2, or x sub 2 minus x sub 1. So we're going to have the -5 and the 3. And the y's, 8 minus -4. Minus a negative really becomes plus. So here we have -8 squared and positive 12 squared, which you'll notice if I square them will end up being the same as these were. So this is 64 because a negative squared is positive, and 144. And if I add together 64 and 144, I get 208. So this is really the square root of 208. So as a decimal, that would be 14.42. AB equals 14.42. So let's actually go back to this again. The distance formula, like we said, D they use for distance, but a lot of times when you're talking about an actual segment, we'll put the letters of the segment here, equals x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. If we flip them and do the y's first and then the x's, it doesn't matter because addition works both ways. Also, if I flipped inside here, it won't matter because you're squaring them. So you would have gotten a positive one way and a negative the other. Once you square it, it becomes positive no matter what. So here is a problem to try. You can pause if you'd like to. Answers are posted online. For example 5, we want to find the perimeter and area of triangle ABC, and then they give us the vertices. So I'm going to plot them. A is at 1, 3. B is at 4, -3. And C is at -4, -3. I know to find the area of a triangle, I need 1/2 times base times height. So I can easily count the base here because it's a horizontal line. So my base is 1, 2, 3, 4, 5, 6, 7, 8 boxes. But the height, I'm actually going to have to draw in. And I know the height should be a perpendicular line to the bottom. So as long as I'm doing a vertical line to my horizontal bottom, that is the height. So that is 1, 2, 3, 4, 5, 6 spaces. So if the base is 8 and the height is 6, we're going to have 1/2 times 8 times 6. So the area is actually 24 units squared. Here's a try problem. Pause it if you'd like. The answers are posted online. Example 6. So we are given 2 points, x and y, but we have variables for their coordinates. And they say find the value of a if xy equals 10. So they're telling me the length of segment xy is 10 units, which means the distance between x and y is 10. So I'm going to start with the distance formula. I'm going to write it out because this is a problem that shouldn't be too difficult, but there are definitely many ways to make silly mistakes. So I know that the distance value is 10, so I'm going to plug that in first. And then I have x sub 1 and x sub 2 here. Notice that they're both something plus or minus something. So what I'm going to do is when I go to plug it into the formula, I'm going to include parentheses around the individual terms I'm plugging in. It's not going to matter for the second ones because they're individual. It's just 2a and negative 2a. They're not adding or subtracting anything to them, so I'm not going to worry about that. I'm just going to do 2a minus negative 2a, which turns into a plus. So the most important part here is we're going to work underneath the square root first. The square root's going to be one of the last things we get rid of. But I need to make sure this negative gets distributed to both things in these parentheses because I'm subtracting everything in these parentheses. So this is going to end up being a plus 1 minus a minus negative 5. So we're going to make that plus 5. All right, so there is our next step. So now I can simplify what's inside the parentheses. So a and minus a cancel, so I'm left with 1 plus 5, or 6. And here, 2a plus 2a is 4a. I'm going to actually square my terms that are inside. So this is going to be 36 plus, when I'm squaring 4a, I have to make sure I square both parts. So 4 squared is 16, and a squared is a squared. So this is as far as I can get now without getting rid of the square root, because I cannot take the square root of 36 plus 16a squared. So I need to get rid of the square root, and I'm going to do that by squaring both sides. So now I have 100 equals, and when you square a square root, the symbols just cancel out there, so I'm left with exactly what was underneath. So there's going to be 36 plus 16a squared. So now this is a regular equation. It is quadratic, but there's no linear term, no a term, so I'm going to solve it by square roots, which means I want to get the term with a squared alone. I'll subtract 36. I'll divide both sides by 16. And last but not least, I will take the square root of both sides so that a is equal to, and now here's the thing, both positive 2 and negative 2 will work because we're not talking about this being a measurement, a length. We're talking about this being an ordered pair, a coordinate, and coordinates are allowed to be positive and negative. So both will work in this scenario. Here's the next try. I would highly recommend actually pausing and trying this one. Answers are posted online. And that is the end of 1.3 and 1.4.